Hi there. Just to say, if you are not watching this live, so if you're watching the replay, we are going to be starting the lesson in about 10 minutes, so feel free to skip ahead. For everyone who has joined for the live lesson today, thank you so much. Welcome. Here are some things you can do while you wait. And yeah, well, this is the first time I've done this, so do feel free to say hi in the chat. Let's just see if that works. And if you want to join in with any of the interactive stuff today, you can go to slido.com and put in that code. And then later on, when we get into it, you can answer some questions there. So welcome to everyone who's joined. Started this a bit early just so that I can figure things out a little bit, but if you're there, do feel free to say hello in the chat, then I'll know that works. And yeah, you can join this Slido thing if you want to take part in any of the quizzes or things that are coming up today. And you can also have a go at some of these questions. Hello, Josh. Thanks for joining. Hello, Bolton, KG, KJP, and hi, John. And if anything isn't working, like if that Slido thing doesn't work, just let me know and I can try to sort it out. And welcome to all the people who've joined just now. Thanks very much for joining. You can join if you want to do the interactive stuff today. You can go to slido.com, put in that code, or just scan this QR code, and then you'll be able to join all the interactive stuff later on. Do have a go at some of these questions here. That just gives away what we're going to be focusing on today. welcome. A few people just joined there. Thanks so much for joining. Just waiting until a couple of minutes after 10 to give everyone a chance to join who wants to join, but go ahead and join that. Go to slido.com if you want to do the interactive stuff today. It's a bit like Kahoot. It's a bit like a boring version of Kahoot. No, I'm joking. It's going to be loads of fun. So yeah, do that. Have a go at these questions. Feel free to say hi in the chat. It seems like that is working, but just to know you're there, that would be nice. And while we're waiting, if you have any questions, feel free to ask. And by the way, well done for finding the different link. The original link I sent out, I messed up. So I tried to make that obvious. I mean, 21 of you made it here, so it can't have been too confusing, but hopefully it's easy enough for everyone else to figure out how to get here instead of the previous one that I made. So I'll just wait another couple of minutes just because I think most people will be heading over to the wrong link and then hopefully figuring out how to get here. But welcome to all the people who just joined. Welcome to everyone who's just joined now. Thank you very much for joining and well done for finding this version. Sorry about the confusion. I think the original link I sent out didn't work, but you're here. So this one is working. Hopefully others can find their way here as well. I'm just going to wait one more minute before I start just to give everyone a chance to join who would like to join. Josh, yeah, just keep them to yourselves for now. I'll put the answers up in a second, but well done if you finish those. Okay, I'm going to get going. So thank you very much for joining me on this Saturday morning. I thought I'd try doing some live sessions for year 13s, basically with the idea of starting some revision. Yeah, I mean, it's pretty early to start revision, except I don't think it is. I think it's good to start early as long as you're not going overboard. And probably the best thing to start with is a recap of some of the year 12 content that you may have forgotten. And I'm going to be focusing on the year 12 content that doesn't get naturally revised by you covering year 13 stuff. Okay, so firstly, yeah, if you want to join that, please do. It should be quite easy. But any issues, you just let me know. For those of you who did these, tried these starter questions, here are the answers. If you're not sure how to do that, don't worry, because I'm going to show you in today's session. So yeah, we had a center of 2 minus 3 and a radius of 5. K could be 2 or minus 8. And then the weird thing about that last one is it basically ends up with a radius of 0. So it's like not really a circle, it's just a point. Okay, so here's the idea for today. Oh, actually, before we start, I just want to check the Slido is actually working. So I'm curious to know what exam board everyone's doing, because I have made it kind of general, but I mean, if everyone's doing the same thing, then it slightly changes what I'm doing. Okay, cool. So this is good to know. So yeah, for the vast majority doing Edexcel, that is cool. That's all going to be great. And for the AQA, that's also great. I've got examples from all exam boards and can talk a little bit about the differences for you guys. And welcome to the not doing exams. Well done for coming as well. Great. Next question, and don't worry, there's not too much of this stuff, but I'm curious to know how you heard, how did you hear about this class? And by the way, when I say like enrolled on Mathematics with Woody, I guess I mean the people who enrolled on it, but not through their school. Some people have a school access to that, and some people just did it for themselves. Great. Okay, cool. Nice to know where you've all come from. Okay, what topic do you think is worth the most in your pure exams? I'm curious to know what you actually think. So do you want to have a go at ranking these? Cool. All right. So yeah, you guys know what you're talking about then. So you're pretty much spot on. So look, across your full A level, there's 300 marks, and I've done some analysis over the last few years. This is actually across all exam boards, but it was very, very similar within each exam board. Across the 200 marks that are available across your pure papers, this is how many marks on average are coming from each topic. So you can see that there's tons of marks coming from year 13 integration, year 13 trig, year 13 differentiation, and also the year 12 versions of some of those as well. Now, obviously you're still learning your year 13. Oh, let me just show you. So all the way down here, there's some like interesting some things from year 12, which really kind of don't really get assessed very much at all. So I'm focusing on the year 12 stuff because you're still in the middle of year 13, still learning content. So we will come in future sessions to year 13 content. So we're focusing just on the year 12 ones. But some of these are just going to get naturally revised by everything you're doing in year 13. So I'd put that as these ones. So year 12 differentiation, yeah, it will come up, but it's going to seem so easy for you once you know all the year 13 differentiation. Same with integration, same for vectors, same for algebra. You'll notice the year 12 trig isn't there, and that's because year 12 trig essentially never comes up. There's almost never a question which is just year 12 trig, so that's why that's not there. But if it did, year 13 trig will sort you out for that. So we're not going to cover those. So that leaves these. Now, here are the ones which I would say are kind of partially revised by what you're doing in year 13. Exponentials and logs, lots of marks from this. Now, you get quite good at exponentials and logs just from all of the functions and differentiation and integration that you do. But there are still some distinctive year 12 problems that need some work. Quadratics kind of gets revised because it crops up all over the place. However, year 12 graphs, like graph transformations, other things to do with like sketching, cubics, quartics, it doesn't really come up much at all. So yeah, so that's worth doing. Circles really doesn't get a look in. And then here are some other ones which sort of get partially revised. So I would say that these red ones don't really get any attention, and they're worth some marks. I'm going to focus on these over my next few sessions. We're going to start with circles today. 6 marks doesn't look like that much, but it's like you can expect one decent sized question. Maybe it's a really simple 4 marker, maybe it's like a sort of really big like 8 marker, but you'll probably get a circles question. So we're going to focus on circles today. We're going to begin by finding center and radius. And I'm doing this because almost every question that you ever get will kick off with some version of finding centers and radiuses of circles. So have a think about how you do this. Here's a circle, find the coordinates of the center and the radius, hence find the coordinates of the lowest point on the circle. So the technique here, and we're not going to spend too much time on this because I imagine most of you are pretty good at this. The technique is to complete the square for the x's and for the y's. So I see x squared plus 6x, and I know that's going to be x plus 3 squared minus 9, which is the square of 3. I do the same for the y's. Y minus 1 squared gets me y squared minus 2y. Subtract the 1 from that, minus 26 equals 0. So in total then I've got x plus 3 squared plus y minus 1 squared, and in total over here I've got minus 36. Kick that over onto the other side, and now I can see what's going on. I can see that the centre of this circle is negative 3, 1, and then the radius is the square root of 36, and so 6. So that's a very, very, very common way to begin these questions. Hence, find the coordinates of the lowest point on the circle. In almost every circles question, it is valuable to do a quick sketch. And so I'll do that here, even if you think you can do it without. That's totally, of course, in this one you can. So a centre of minus 3, 1. So that's over here somewhere. And a radius of 6. So if that's 3, 6 is going to go out to here. So we've got a circle looking like something like this. Excuse the appalling messiness of this. And so the lowest point on the circle is going to be right down here. So directly below. So I can just see that if my centre is minus 3, 1, I'm going to go down a full radius of 6. So my x coordinate here is still minus 3, but my y coordinate is 6 below where it was. So we're at minus 5. If I do mess up at any point, please just feel free to let me know in the comments, which I'll try to check every couple of minutes or so. All right, here's a slightly harder one with a slightly more advanced part C, but these are quite easy once you kind of get the hang of them. Whoops, don't do that yet. So we've got points A and B with these coordinates respectively. Find the coordinates of the midpoint. So another routine, essentially they'll mostly try to, the part A is usually trying to like find out what circle we're dealing with. One way can be this sort of completing the square form. Another one is where they give you some information to find out what you need about the circle. So here we've got two coordinates, and it says find the coordinates of the midpoint. So, okay, midpoint of two points here. Hopefully that's straightforward. Just the average of the x, average of the y. So 5 plus 13 is 18. Divide that by 2, and it's 9. Minus 1 plus 11 is 10, divide that by 2, and that's 5. So there's the midpoint. Now, given that AB is the diameter of the circle, find an equation. Again, a relatively common question. If AB is the diameter of the circle, then the midpoint of A and B is the centre of the circle. So we've got the centre of the circle. All that we need is the radius. Now, the radius is just going to be the distance between the midpoint and either of these. It will be the same. So the radius, and we're going to do radius squared here because we're basically setting up Pythagoras' theorem. It's the difference in x values. So the difference between 5 and 9 is 4. You could put 4 or minus 4, but we're going to square it, so it doesn't matter. Plus the difference in y values. So that's a difference of 6. Add those together. It's early. I'm going to use my calculator. And it's 52. Calculator not working, but I believe that's 52. It is 52. So there's the radius squared. I actually don't care for the radius really. It's the radius squared that I actually wanted, because now I can find the equation of the circle. It's x minus the x coordinate of the centre squared plus y minus the y coordinate of the centre squared equals the radius squared. So super common way to begin these. Okay, This one here I've seen crop up in like 2 of the last 5 papers in Edexcel. Have seen it crop up in AQA once in the last few years as well. So find the maximum possible distance from the origin to a point on the circle. This is a bit confusing until you draw a sketch, and when you draw a sketch it's fairly easy and fairly obvious. So let's get a sketch of this circle. So it's got a center of 9, 5 and a radius of, okay, the radius is root 52. It's useful to know for my sketch roughly what that is. It's a little bit bigger than 7. So let's get a little sketch here. So 9, 5 is going to be something like that. And then a radius of 7 means it is going to dip below the y-axis, but it's not going to, so the x-axis, but it's not going to cross the y-axis. So something like that. So we want to know what the maximum possible distance is from the origin to any point on the circle. So how do you think that's found? Well, the way to do this is to draw a line through the origin that goes straight through the center of the circle and out the other side. This point here is as far away as you can get on the circle. Now, I wonder whether that's intuitive or obvious to you. Some people find that an obvious fact. Other people think, like, why is that the case? It's basically because as soon as you start rotating going around to this point here, you know what, that is quite hard to prove that that's the case. We could prove it using things like differentiation. That would be very, very, very hard. But I think it's more obvious that that's the closest point to the origin. So by drawing this line, it gives you the furthest point from the origin and the closest point to the origin. Of course, we could have used the same technique, by the way, for any point. If I was looking at the, some random point over here, I'd draw a line from there through the center of the circle, and those intersection points would be giving me the closest and furthest points. Okay, well done, Josh. You got that. So how do we find that distance? Well, I know that this radius here is just the radius of the circle. So this distance between here and here is just the square root of 52. And then all I need to do is add that on to the distance between the center of the circle and the origin. And the distance between the center of the circle and the origin is just, I can just find Pythagoras. So let's call that d for distance. So the distance from the origin to this point here is the square root of 9 squared plus 5 squared. So square root of 81 plus 25 is the square root of 106. So what that means is the furthest possible distance from the origin is just the distance from the origin to the center, which I just worked out, root 106, plus the radius. And I know that root 52, I think, simplifies it like to 2 root 13 or something, but don't worry about that. And here's our answer. Now, if it had asked for the minimum distance, it simply would have been the distance to the center minus the radius. So, yeah, that's a question I've seen crop up a few times. All right, I've got a quiz question coming up for you, but just so you know the structure of this, in the description, I put a link to a worksheet that I've created that goes with this video, not to do now, but to do later. And basically, I've called this level 1, center and radius, and in that worksheet, you've got a bunch more questions to try simple center and radius problems. It's also got mark schemes and model answers. So after the lesson or sometime, go ahead and download that worksheet, and you can basically put what you've done in this lesson into practice in those worksheets. Okay, let's try a quiz question. So join the quiz. So hopefully you're still there on Slido. If not, you just go to slido.com, put in that number. If you don't want to join the quiz interactively, that's totally fine. Okay, hopefully you can also see this question. So a circle has equation x squared plus y squared plus 8x minus 10y equals 9. Firstly, all I want is the center of the circle. So find the corners of okay, the question says find the center and the radius, but just for this part of the quiz, you're just finding the center of the circle. And if you've already finished this question, do feel free to just finish part A and do part B so you're ready with your answers. Okay, so let's see what you guys thought. Okay, almost everyone got that right. Well done. The reason why it's not 4 minus 5 is when we did the completed square form, we got x plus 4 squared. And if you got x plus 4 squared, then it's negative 4, and the same for y. Okay, don't need to go through that. Now, what's the radius? So same circle. So hopefully you're ready with answers. Okay, let's see what people thought. Final answers in. Okay, well done. Yeah, it was 5 root 2. Just to zip through that and then get a little sketch ready, we had x plus 4 squared minus 4 squared, and then for y minus 5 squared minus the square of 5 equals 9, giving me x plus 4 squared plus y minus 5 squared. That's why the centre was negative 4, 5. And then over here, it's 9 plus 25 plus 16 is 50. And I think I caught a couple of people out. That's r squared. So r is the square root of 50, which is 5 root 2. Okay, so the next question is about minimum distances. And so just to help you out, let's think about what a sketch of this looks like. The circle has center minus 4, 5. So minus 4, 5, something like that. And then what is the square root of 50? It's just a touch over 7. So that means it is going to drop below the x-axis, and it's going to drop, and it's definitely going to go over the y-axis. So something like this. Find the minimum distance from the origin to the circle. That actually doesn't look so good, does it? I think I've drawn something wrong, because at the moment my sketch there is making it look like it goes through the origin. So I've got to draw it a little bit smaller, so something like that. Excuse the awful sketch. And our minimum distance then is going to be found by considering this line here. So with that sketch in mind, have a go at the minimum distance from the origin to the circle. I think I've got this one wrong. So if you're getting a weird answer, don't worry. This actually shows the importance of sketching, which I think I did not do when I wrote this question. Okay, actually, this is kind of interesting because there is a nice answer, but the answer I put here is actually wrong, and I'm kind of interested to see why. So lots of you put the thing which I thought was the right answer, and here's why it's wrong. Hey, well done to all you guys who got all of these correct. Nice one. Well, I say correct. You got it wrong in the same way that I got it wrong. All right, the issue with this last one is actually if you see that answer that you put, this one here, it actually comes out as negative, which makes no sense until you realize, as I have just done, that actually my sketch back here, I was kind of getting in the muddle of this because actually the circle contains the origin. Here's the thing, if you work out the distance to the origin, the distance from the center to the origin, let's call that d, is the square root of 4 squared plus 5 squared, which is the square root of 41. And the radius is bigger than that because the radius is the square root of 50. So the circle actually contains the origin. So minimum distance, we're still going to use the same method, right? The minimum distance is still this distance here, but it's not distance to the origin minus the radius. It's the radius minus the distance to the origin is going to give you this point here. So the actual answer should have been root 50, which is 5 root 2 minus root 41. So that's actually interesting. I hadn't really considered that before, but you can still use this. But if you get a negative answer, it probably just means that the origin was actually inside the circle, which is interesting. All right, so do have a go at some of those questions for yourself on the worksheet. We're going to look at a more challenging topic now, which is forming inequalities. By the way, there's 3 levels that we're going to go through. So a very, very common kind of part B or part C question is one that asks you to use logic to form some kind of inequality. So here's an example. A circle has equation there. Find the coordinates of the center. So absolutely classic way to kick things off is to get you to find something about the center of the circle or the radius. So let's do that. I'm just going to zip through this because we've already covered this, but we're going to get x plus 2 squared minus 4 plus y minus 6 squared minus 36 plus m equals 0. So I can already see what the center is. It's minus 2, 6. So there's my answer to part A. In your exams, please don't write answers on top of the questions. I'm just doing it to save space here. Okay, they haven't asked for anything else, but I'm no doubt going to use this in a moment. So given that C does not cut or touch the x-axis, find the range of possible values of m. Okay, for this one, you really must do a sketch. I think these are exceptionally difficult to get right without a sketch. So what's that going to look like? Well, I've got the center, which is minus 2, 6. So minus 2, what is that? It does not touch or cut the x-axis. So minus 2, 6 is, say, here. Okay, so what I've got to imagine is how big could this circle be if it did not cut or touch the x-axis? Well, maybe it's a tiny circle, but it could be bigger than that. But if it gets too big, it will actually touch the x-axis. So I'm going to draw in the circle that's sort of the upper bound of how big it can be. So I'm drawing it so it is touching the x-axis, but obviously we're going to need the radius to be smaller than that. So here's the sketch that we're going to use. I can see that currently this distance here is 6. So basically, in order for the circle to not touch or cut the x-axis, I need the radius to be less than 6. So that's the condition that I get from the fact that it doesn't touch or cut the x-axis. Radius is less than 6. But there is a condition which is always true for any circle, which people often forget, which is the radius also has to be more than 0. If it is 0, you don't have a circle, you've just got a point. So I've actually set up 2 inequalities here, and I'm going to solve them both. So let's shuffle this around and see if we can get an expression for what the radius is. By the way, Josh, I just saw your question about the previous one, and yes, we can just take the modulus of distance minus radius. Good point. Try to check the chat every so often. So rearranging this, I get x plus 2 squared plus y minus 6 squared equals, well, minus 4 minus 36 is minus 40, so add 40 to both sides, subtract m. So that over there is the radius squared. Now, if r is less than 6, well, what's the condition for r squared? Well, normally you've got to be really careful with squaring both sides of an inequality because it can mess up positives and negatives. However, we know that r is positive anyway, so we are allowed to do that. What I mean is, if r is less than 6, then r squared is less than 36. Normally that's not okay, because if r was minus 100, that is less than 6, but minus 100 squared is positive 10,000, which isn't less than 36. So in general, that step is wrong algebraically, but if you're dealing with something which is definitely positive, like a radius, that step is okay. So r squared less than 36, we know what r squared is. It's 40 minus m. So 40 minus m is less than 36. Solve this, we get 4 is less than m. So m greater than 4, that's our first condition. Now let's do the r greater than 0. So if r is greater than 0, r squared better be greater than 0 as well. Again, that's a weird thing to write because, well, if r was could be negative, then that would always be true anyway. But here's r squared. R squared definitely has to be greater than 0. So 40 minus m is greater than 0, which tells me that 40 is greater than m. And so I end up with m needs to be less than 40 but bigger than 4, and so the full condition is 4 is less than m is less than 40, and we're done with that question. So yeah, so watch out for these ones where you need to form your own inequality. Seen someone's put m is between 4 and 36, but I think it's less than 40 is the condition there. Tell me if you think I've made a mistake there and that's wrong. So yeah, the key thing is there's often this hidden inequality, the fact that the radius is not only has to meet the kind of condition of the question, but also always has to be positive. Okay, let's move on and look at another question where we've got to form an inequality based on the information given. All right, bit of a longer question here. Circle C is tangent to the y-axis. The x-coordinate of the centre is k, where k is a positive constant. Given that the maximum y-coordinate of a point on C is 10, find the coordinates of the centre in terms of k. Again, this is kind of hopeless unless you try to sketch it. Okay, tangent to the y-axis, rough sketch up here. Tangent to the y-axis means it's like that, or that, or that. That's right, it's just touching the y-axis. But we know that the x-coordinate of the centre is k, and k is a positive constant. So the x-coordinate of the centre is positive, so it's like maybe this one or maybe this one. Okay, what else do we know? Given that the maximum y-coordinate of a point on C is 10, find some stuff out. Okay, so clearly it's not this circle because the maximum y value there isn't 10. What it means is it must be going up to the line y equals 10. To give it a fancy terminology, it's tangent to the line y equals 10. So what can we say about it? Let's do a better sketch. I now know that it's tangent to the y-axis and it's just skimming the line y equals 10. So that's the point 10 there, and it's got a centre of with an x value of k. Okay, well, if its x value is k and it just touches the y-axis, then that means the radius is k, right? That distance there must also be k. And so must therefore this distance, because that's just a radius again. So that means that the y-coordinate is just k less than 10. If I start at this max point here and I go down by k, I get 10 minus k. So find the coordinates of the centre of a circle in terms of k. We've now got it. It's k and 10 minus k. I think that's really very, very hard to do without a careful sketch. So really strongly encourage you to try to concentrate on that sketch because it kind of sorts everything out. Okay, given that circle lies in the first quadrant, what a horrible question, because everyone forgets what these quadrants are. The quadrants are 1, 2, 3, 4. So the first quadrant is the one where x and y are both positive. So what could k be if it has to be in the first quadrant? Well, as k gets bigger and bigger and bigger, the radius of the circle increases and increases. And it can increase up until it starts poking out under the x-axis here, because then it's not all in the first quadrant. So what I've got to do is update my picture. So it's now going all the way down. It's just touching the x-axis like that. And it's going all the way up to 10 still. So its centre is still k and 10 minus k. But the question is, find the range of possible values of k. Well, what's the biggest that k could be? I think the biggest that k could be is if, well, we know that this distance here is k, and that's a radius, so this distance is also k, and then this distance is also k. So the total height of the circle, which is 2k, in this case would be equal to 10. So the absolute maximum value for 2k would be 10, so we could say that 2k is less than 10, and then k is less than 5. Now I suppose we could say less than or equal to 5, because if it's on the x-axis, that's still in the first quadrant, so I think that would be all right. And then for it to even be a circle, k has to be a positive constant, so k is greater than 0. I guess that's not true, it just tells us it's a positive constant. If it were 0, then it wouldn't be a circle anyway. So there's one where there wasn't really any algebra to do. It was all from the picture. So yeah, diagrams are just so essential to these. Again, the worksheet that you can download from the link in the description gives you a bunch more of these sorts of questions. All right, I want to look at one more pretty challenging one. I think I'd say this is like, it's not as hard as it gets, but like at the upper end of this inequalities one. Okay, so we've got this equation here, messy looking equation with k's all over the place. Show that the radius of C is that. Well, okay, we know what to do. Even however grim it looks here, it's completing the square to find centre and radius. So can we do that? Well, yes, because x squared minus 2kx does well, we can complete the square as just x minus k. Square that, and that would give us the x squared and the minus 2kx, but we've got to subtract k squared. For the y, well, that one's a bit easier. It's just y minus 1 squared minus the 1, then plus k and plus 3 equals 0. So the full equation is going to be x minus k squared plus y minus 1 squared, and then over on the other side we've got k squared minus k, and then that's 2, so minus 2. Okay, that's good, and therefore the radius is the square root of that. All right. Algebraically a bit fiddly, but conceptually it's still just completing the square. Okay, now given that the radius of C is less than 2, find the possible values of k. Okay, well, that seems like we just need to set this root less than 2, but don't forget the condition which is always true of a radius, it's positive. So I'm going to have to set up two inequalities here. The first one is that this radius is less than 2. Again, we can do this algebraically dodgy thing of squaring both sides. It's fine because the radius is positive. So if r is less than 2, then r squared, which is k squared minus k minus 2, would be less than 4. Right? If r is less than 2, r squared is less than 4. So I can just solve that. I am a massive fan of just using your calculator for these quadratic inequalities. I know some people like to, just kind of do it the long way, but to be honest, you never get any extra marks for showing loads of working on these. So just if your calculator doesn't do this, get one that does, because it's just guarantees you don't mess this up. So the solution to this is that k is between -2 and 3. Okay, so I definitely need that to be true. And now let's solve the other inequality. The other inequality is that r must be positive. So if r is positive, r squared, of course r squared is positive, so k squared minus k minus 2 must be greater than 0. Again, just do this on the calculator. These are so easy to mess up by hand and so easy to get your calculator to do. So the solutions to this ends up being that k is either less than -1 or k is greater than 2. And here's the logically slightly fiddly bit. I need both of these to be true. So if you find that I find that conceptually quite a lot. Here's how I would do it. Just old-fashioned like number line and showing it with like bars and stuff. Here's how I would do it. I get a number line which covers the full range, so that's going to be down to -2, -1. I know it seems naff writing out a number line, but like it's more naff to get the question wrong. And then here's what I'd do. I would get something like this and say, well, let's not do red, that makes it look like it's wrong. So this one here is true between -2 and 3. So -2 up to 3 is where that one's true. And then this one is true either when k is less than -1 or when k is greater than 2. So then all I need to see is, when are both of these true? What is the region where both of those inequalities hold? And you can see it's this little bit between -2 and -1. So when k is between -2 and -1, we're good. And then also when k is between 2 and 3. So there's my solution. The solution has two regions like that. 5 marks, I think relatively fiddly, but the thing to bear in mind, and the structure with all of these is don't forget that r always has to be positive, and then use the information to form another inequality. If there's two of them, you've got to kind of find a visual way, or I prefer a visual way of seeing when they're both true. Okay, let's try a bit of a quiz on that. Here's the question that's coming up in the quiz. So let's have a go. I know some of you actually have to sort of, if you've just got one device, have to drop out of the call to do this. I know that's annoying. Apologies. So here's an equation: x minus 1 squared plus y plus 5 squared equals 4 minus k, where k is a constant. Given that the circle is tangent to the y-axis, find the value of k. Do sketch this out. This is going to be very, very hard if you don't sketch this out. And if you're not doing this on Slido, that's totally cool. Just just have a go at the whole question. And if you finish this little bit, just go on and work on the next bits. Okay, let's talk through this first part. I know I haven't given you loads of time to do a 3-mark question, but I want to keep moving. Okay, 75% of you said 3, which is correct, which is fab. Well done. Let's think about why that's true. Sketch of the circle. The center is 1 minus 4. So 1 minus 4, something like that. And it's tangent to the y-axis, so it's looking like this. So there's the point 1 minus 4, and I can learn from that that the radius of the circle is 1, because the distance from here to here, well, is just 1, and that's the radius. So the radius is 1, and therefore the radius squared over here must also be 1. So 4 minus k equals 1, and that gets us to k equals 3. Okay, just to give you a heads up on this next one, given instead that the circle does not touch the y-axis, find the range of possible values of k. So if it does not touch the y-axis, it's got to be, well, the radius has to be smaller than that. So think about that inequality, but the radius definitely always has to be positive. So we've got 2 inequalities there to set up, so go ahead and try that. Oh, that is not the right question. One end of a light elastic string. Okay, I don't know why that question has come up there. Well, what can we do? Try to just remember the question and don't answer this this mechanics question, which looks like a great question. Oh, I know where that comes from. I'm going to be telling you about that in the next slide. Okay, just because we don't have tons of time left, let's see what we get with this. K is between 3 and 4, although a bit of a debate about whether it can be equal to 3. So let's see. Okay, well done, Josh and Viren, and well done to everyone else who got those correct. Okay, let's have a look at this. So we had this diagram where it was tangent to the y-axis. It had this center of 1 minus 5, and it was, well, it couldn't even touch the y-axis. So the situation there is that if the radius is 1, then it's going to touch the y-axis. So the radius is going to have to be less than 1, and definitely less. It does not even touch it, so strictly less than 1. And then the radius definitely has to be strictly greater than 0. If the radius is 0, you don't have a circle, you've got a point. So this is our radius squared, but since it's definitely positive anyway, we can just say that 4 minus k has to be less than 1. And that gets us that k is greater than 3. But we also have that our radius squared, 4 minus k, has to be positive. So that gets me that 4 is greater than k. So 4 is less than, k is less than 4. So it's between 3 and 4, but the conditions are strict on both sides, because if it is 3, it touches the y-axis, and if it is 4, it's not a circle. Okay. For any of you who don't already know, quick plug of my complete A-level maths course. That is, yeah, it's got like over 10,000 students, and it's basically videos covering the whole A-level course, over 70 hours of videos, and so it's massive. More than 500 quizzes, got more than 3,000 reviews, pretty good reviews. So if you don't already know about that, do check that out. Link is in the description. You can get 30% off that with the code COMPLETE, so do check that out. Also, you can refer a friend and get yourself a £25 Amazon voucher, and you get your friend will get £25 off the course as well. Again, details in the description there. I have a new course as well, which is called Aiming for A Star in A-Level Maths. I literally released this 2 days ago, so I'm really pleased with it. It's basically it's for people who are aiming for A Star. It covers all the absolute hardest questions that have come up. It's got practice questions linked to all of those. So I basically work through the really hardest questions and then have created loads of similar questions for you to try yourself. You can also get 30% off that with the code A Star. So do check that out. I'm really pleased with that. I'm going to be adding to it as well. Currently it's got pure and mechanics, and I'm going to be adding more mechanics and stats. So it's going to be a really cool course. If you're enjoying the lesson, do feel free to donate. There are some links in the description where you can donate, and yeah, I mean, if you pick the first link, you can even get your name scrolling across the screen at the bottom, which is pretty cool, I think. Okay, on with the maths. So level 3 are discriminant problems. Oh, question, by the way, I've just seen, what's the difference between this course and those on Udemy? Of the complete course, it's very similar. It's just got a few more past papers, but the A Star course is not on Udemy. Also, someone said, are those courses board specific? No, they are not. They are, because the spec is the same, the teaching content is the same for all of them. When there are differences, I'll always advertise that in the videos, like this video is only for people doing whatever, Edexcel. But then I do have practice videos going through exam questions, which are board specific. So the complete course is not board specific. It's good for everyone. All right, we only have like 10 minutes left, but I'm happy to go on till like 10 past or quarter past. If you do need to drop out, then that's obviously fine. Okay, discriminant problems. These are the most common question in Edexcel by a mile. They are in, I'd say, like 80% of all circles questions end up with one of these. There was someone here, a few people here doing AQA. These probably are the second most common type of problem in AQA. They come about 50% of the time. AQA has no, probably more, like 60-70%. They have a little bit more like tangent and intersection of line and circle questions. I've got some of those in the question pack for you guys. So a circle has equation with that line as a tangent. Find the possible values of k. I'm going to show you this in Desmos, and I would really, really, really strongly encourage you. Obviously, you don't have Desmos in your exam, but while you're learning how to do these and developing intuitions, just keying things in, having a look is just such a good way of doing this, and it's really, really easy to do. So I'd massively encourage you to play around with that. So what do I need? I need the circle, which is x squared plus y squared minus 4x minus 14 equals 0. So there's the circle. And then you've got this line, y equals 2k minus x. Now, if I just type that in, y equals 2k minus x, it says add slider. Yep, I just hit OK. And now I can move this about and see what's going on. Now, in the end, obviously, you need to be able to imagine this. It's helpful to be able to imagine this in the exam. This kind of makes sense because 2k minus x is a gradient with a y-intercept of -2 and a gradient, no, y-intercept of 2k and a gradient of -1. So that makes sense. You've got a gradient of -1, but with a y-intercept that varies. And what you can see is there's basically three possible things. Either the line does not intersect the circle, or it intersects it at 2 points, or it just intersects it once, i.e. it's tangent to the circle. Hopefully you know that when you do simultaneous equations with a straight line and a circle, you end up with a quadratic equation. And this is where the discriminant comes in, because this line here intersects the circle at 1 point, so leading to a quadratic with just one solution. Quadratic with one solution has a discriminant of 0. So whenever you see a line is tangent to a circle, in your head you should be thinking, okay, discriminant equals 0. If it were this, well, that's discriminant is negative, right? It does not intersect the circle, and here we've got discriminant as positive. So try to have these sketches in mind. Obviously, you're not bringing these into the exam with you, but you know that's you learn to do that. Cool. Oh, thank you to the people who've already donated. That's very kind. See, name scrolling. Oh, God, that worked. Didn't think that would work. All right. So here's how this goes. X squared plus y squared. So given that it's tangent to the circle, we're basically going to set up simultaneous equations. And I'm simply going to sub y into here. So x squared plus y, and that's 2k minus x squared, minus 4x minus 14 equals 0. And here's the key thing. Tangent to the circle means that this quadratic, once I've expanded it all, once I've done everything, should have a discriminant that's equal to 0. There's no shortcut here. All I can do is expand this whole thing and carefully get my a, b, and c. So expanding this, I get x squared plus, okay, 4k squared minus 4k x plus x squared. That's that one expanded. Take your time with those. That's pretty easy to get wrong. Minus 4x minus 14. Okay, so in total, what have we got? We've just got 2x squared. How many x's have I got? I generally would just advise opening up a bracket and saying I've got minus 4k of them here. And I've got minus 4 of them here and dropping the x there. And then what's left over is this 4k squared and this minus 14 here. And now I've got my quadratic set up with my a, b, and c, which is ready for the discriminant. So b squared minus 4ac has to equal 0 because it's tangent. So b squared minus 4 times a times c. And this looks like it's just leading me towards a quadratic in k. It's a bit of a mess to actually solve this, but just rely as much as you need in your calculator. A nice little trick, by the way, if you're ever expanding a bracket squared and both terms are negative, I typically just make it plus and plus. You're going to be squaring anyway, so it doesn't matter. You obviously can't do that if only one of them's negative and one of them's positive. Expanding this, I get 16k squared plus 32k plus 16. Then it's minus 8 times that, so that's minus 32k squared. And then it's minus 8, and I'm definitely going to do this on the calculator. Minus 8 times minus 14 is plus 112. Do shout at me if I make a mistake. What have we got then? We've got minus 16k squared plus 32k plus 100, oops, that's messy, plus 128 equals 0. I'm not even going to think about trying to simplify or do any of that in my head. I'm just going to key it straight in. Minus 16, 32, 128. And I get k equals 4 and k equals minus 2. And we're done. And, you know, while you're learning this at home, I would say go ahead and do have a look in Desmos and just sort of check that that actually checks out. So k equals 4. Yep, it was tangent when k was 4 and when k was -2. I find that both like reassuring. Obviously, it means you got it right, but also it's just developing intuitions gets you to the point, hopefully, where when you're in the exam, you can kind of have like a little version of Desmos in your brain, if you like. Okay, I think we've got time. Yeah, it is 11 now, but I would love for you guys to stay because I want to go through a couple more examples, and I've also got a little bit of feedback which I'd like from you at the end, if you are willing. So I'm going to go through one more example. Okay, someone's asked a good question, by the way. Do I think it's worth investing in a graphical calculator for A-level maths? The answer is basically yes, but only if you use it loads. You've got enough time if you get it now to get really, really familiar with it, and then it is a good investment. Don't get it because you think it's just like going to provide some nice shortcuts. They take quite a long time to get used to, and if you don't use it a lot, then it will just slow you down. So if you're interested in it and you commit to using it a lot, then yes, it's really good and really valuable. It's great for stats. Obviously great for drawing graphs. So yes, it's a good investment, but don't think it's like, oh, just get that and it will make things easier. Get it if you plan to use it a lot, and then it's brilliant. Okay, let's have a look. Which one should we do? Let's do this one here, slightly harder one. This one was a fairly similar one. The difference with this one, by the way, and you can go and check this out, or you can watch this afterwards on replay, is that it's got a y-intercept of -2, which means it's basically, we don't know the gradient, it's mx minus 2, and what you would be doing is the same thing as the previous one, and noticing that 2 distinct points means that b squared minus 4ac would be positive. So you just have an inequality there as your solution. I want to go through this one. It's a little bit more awkward. Here's a circle. K's all over the place. Find in terms of k the coordinates of the center and the radius. Classic start to the question. So x plus k squared minus k squared for the x's, y minus 2k squared, and then minus 4k squared plus 12. So all sorted out. And another reminder in your exams, do not write your answers over the questions, put it in the space provided. Do as I say, not as I do. Giving us 5k squared plus 12. Okay, so the coordinates of the center of the circle is minus k and 2k. And the radius of the circle is the square root of that. Okay, given that this is a tangent to the circle, find the possible values of k. This one is going to be way harder to visualize what's going on. I have no idea what's going on with this as I vary k. It's actually quite fun to check it out in Desmos, but I'm not going to do it now because that's something that would be genuinely impossible to imagine in the exam. So this is the same thing as before, it just looks messier. I'm subbing y equals x plus 2 into this equation. Subbing in x plus 2 into this is something I don't particularly want to do because expanding x plus 2 minus 2k all squared is just really awkward. So I would actually suggest expanding the whole thing first and then subbing in. You're going to have to expand anyway, so I would just recommend doing that, which basically involves going back to this. Oh, you know what, actually, don't even bother with this. You have it expanded there. Okay, what's the message from that? The message is it's much easier to sub something like this into an expanded form than a factorized form. So x squared plus y, which is x plus 2 squared, plus 2kx minus 4ky. Don't try to do any of the expanding in your head, that's a recipe for disaster. Plus 12 equals 0. There is our quadratic in x with some k's in it. Expanding all of this, x squared plus 4x plus 4 plus 2kx minus 4kx minus 8k plus 12. Hopefully I didn't make any errors there. Put that all together. We could divide by 2, but honestly, why risk getting that wrong? Because you're just going to put it into your calculator anyway. You know what, maybe that's not such a crazy thing. Let's see. 2x squared. Now the x's, we've got, well, I've got 4 from here, and I've got 2k minus 4k, so that's minus 2k. X, and then what's left is 4 plus 12, which is 16, and then minus 8k. You know what, I would say this is a good point to just divide everything by 2. It's going to make finding the discriminant a bit easier. So x squared plus 2 minus kx plus 8 minus 4k. We're nearly there. We just need to set the discriminant equal to 0. So we've got b squared minus 4 times 1 times 8 minus 4k equals 0. Expanding this, I get 4 minus 4k plus k squared. Expanding this, it's minus 32 plus 16k equals 0. And that gives me k squared, how many k's? Plus 12k, and then minus 28 equals 0. And minus 12 in the first part. Have I messed up here? Someone thinks I've messed up. I may well have done. I think I haven't. No, I think but tell me if you disagree. I don't think I've messed up there. So we end up with k equals 2 or minus 14. So that I'd say is algebraically at the kind of top end of difficulty. In the radius. Oh, yeah. Great point. That should be. Oh dear. Marks lost. Great point, Josh. You are correct. I am wrong. Okay. Right, I'm not going to go through any more examples. Do check out the worksheet so you can practice all of this stuff. I did have a section which I didn't get onto, other styles of questions. I didn't quite know how long everything would take, but again, there's more. You can go back to this video if you want to try some of these. That one's quite a nice one. That's another one. That's another one. So go back and watch the video if you want to go through some of these. What I'd be super grateful for is if you could obviously buy my course or tell your friends about it. Do feel free to chuck me a donation. I'd be unbelievably grateful for any of that. That would be so nice. And then, yeah, tell your friends about this as well. Finally, I'd be very grateful if you have any feedback. So this is not going to come up on the screen, by the way. So hopefully when you go to whoops, I need to open that up again. Keep the survey. Okay, I might need to open that up again. Yeah, massively grateful if you could give feedback. It's not going to come up on the screen, so yeah, don't worry about that. Please be honest about that. Basically, I'd just like to know, if I did this again, would you be interested in coming? What sort of topics? And then just curious to know, kind of like how you found out about this and that kind of thing. I'm going to stick around for another 10 minutes or so. So if anyone has any questions, I'm more than happy to answer. Thank you very much. And great to hear you do it again. Thanks for all your questions. I'm not going to mute Josh. He has corrected an error I've made, which makes his participation more than worth it. But thanks for your thoughts. So yeah, my plan, just so you know, is to do something like one of these every 2 weeks. I probably should have said I will be doing another one in 2 weeks' time. I will send out messages with details in basically the same via the same way I did last time. So I'll send out a message on Udemy, so students there should hear. I'll send out a message through Mathematics with Woody if that's how you heard about this. If your school told you about it, well, I'll try to tell the schools again. But also, if you just join, check out the Mathematics with Woody YouTube channel, you'll see I'll schedule upcoming live events. Cool. Thanks, guys. Thanks for all the nice comments. Cool. Appreciate that. Yeah, my plan is to stick with the year 12 revision just because that can easily get lost while you're learning all the year 13 stuff at a rate of about one class every 2 weeks. From March, I'm probably going to pick up the pace to something like one a week, and we'll start looking at some year 13 topics as well. During the Easter holidays, I might do a few more, focusing on year 13. So yeah, do come along, check out the scheduled live classes in YouTube Live. That's where I'll kind of have it all. And do please tell your friends. We had about 40 people at one point today, which is really cool, but the more the merrier. So next class probably on the 31st, but I will confirm. I'm around for another few minutes, so do ask if you've got any questions. And do check out my Aiming for A Star course. I think it's really, I think it's a good one if you are aiming for A Star. And the last plug for donations, if you fancy chucking some change to me. Pleasure. Thanks very much. Okay, well, if people don't have any more questions, that's all. I'll see you guys hopefully back for more soon, probably in a couple of weeks, but do just check out on the YouTube channel to see when the next one is scheduled for. And thanks for all of your participation. This has been lots of fun and I hope it's been useful. See you guys soon. Bye-bye.